Okay. The next presentation by Federico Viani deals at first with the surveillance of museums using sensors. The core of this presentation, though, is not about sensor and technical stuff. It really opens towards more advanced platform for museum, giving some new tools for establishing smart cities concept. Federico Viani got his master and PhD degree in telecommunication engineering from the University of Trento. His main interest, you bet, is in wireless sensor networks, antenna synthesis and design, and electromagnetic inverse scattering technology. I'm sure that you know all what it is. And well, this is marvelous to see how deep technician may also be part of culture in this melting pot, which is smart cities concept.
Thank you, Mr. Chairman, for your kind introduction and welcome. I'm going to present a work that is a joint collaboration with the city of Florence also, that give us the opportunity to test, deploy and test the system in this wonderful room. So let me start with a first general overview of this talk. I will briefly introduce what we consider a decision support system for museum management. Then I will show you the architecture of the system we developed and some processing of the data we are able to acquire, the deployment here within the Salone del Cinquecento, some preliminary experimental results mainly related to the monitoring of the environment and also to the estimation of the indoor occupancy, and then some conclusion and the next steps. Okay, let me show you the general overview of a museum management flow. Starting from the decisions of a museum manager, we go down to reach some high quality services. But we think that we can improve this process by adding some smart system that measure information and acquire data from the museum itself and support the decisions of the museum managers. Finally, the improvement is in the decisions that are better and the services provided to tourists are of higher quality. We can just say that there are a lot of examples of decision processes that can be mapped in this plan, do, check and act cycle. Let me do just a simple example related to the organization of the events. So the manager of the system has to decide the time, the schedule of the events and the news that he provides to the tourists. Then he does this schedule. Then in some way we have to check the condition of this process and take some corrective actions if needed in order to improve in this loop the quality of the final service. Okay, we are mainly focused in these two phases of check and act. For us, in particular, in the check phase, because our focus is on the monitoring system able to represent in some way the status of the museum, and in particular, the status of the indoor environment and of the presence of people, of tourists, within the rooms of a museum. There are, of course, many challenges to be faced up. For environmental monitoring, first of all, we have to face with costs, real-time performances, low pervasivity, and the robustness of the architecture, and so on. So we decide that the solution we proposed is based on a wireless sensor network architecture for ubiquitous monitoring of heterogeneous parameters within a museum. The architecture we implemented to acquire this data are based on the wireless sensor network technology that is composed by a finite set of standalone low power and low cost devices that communicate wirelessly and are able to acquire information about the environment. In particular, the hardware platform we integrated is, of course, very small because we need to guarantee low impact from the point of view of the tourist. We have to acquire different kind of information about the environment. In this case, we just integrate two very simple kind of sensor to measure temperature and humidity. We have to guarantee long lifetime of the system, good coverage throughout the indoor, throughout the rooms of the museum. Once we have collected this information, we would like to estimate in some way the occupancy of tourists within the museum. Our idea, facing these challenges of course, privacy still impacts, the reusability of already installed technologies, costs, and so on. The solution we decided to apply is that of exploit the environmental information in an indirect way to extract and estimate the occupancy value of people within the museum rooms. The principle is very simple. You know that there's a direct relation between the number of people in a room and the value of the environment and environment characteristic like temperature and humidity. You see, when the museum is void, we have lower humidities, and when the number of people increases, of course, also the environment is in some way affected. How can we exploit this relation between the environmental information and the number and the density of people within a room? Our idea is based on the exploitation on the development of a learning by example method that is able to estimate, to extract the unknown and complex relation that exists between the output, that is the occupancy of people, and the different kind of inputs we can give to the system. For example, the environmental data, or also some additional information or additional knowledge we know about the museum. The process is a two-step process. The first is the training phase and the second is the test phase. I go very quickly here to show you better the results. During the training phase, we are able to learn the system starting from a finite set of known relation of input and outputs. Once we constructed this function, the red line you see, we are able to say, okay, now I can put, during the test phase, new data that I never saw before and extract an estimation of indoor occupancy. Let me move to the deployment we did here in the Salone del Cinquecento. We deployed 22 sensors indoor and 1 sensor outdoor. We deployed them at 3 different heights, different layers, and more in particular, I have some picture to show you also the installation process. The higher layer, layer 3, is at 18 meters. The sensor have been attached to these anchor cables and picked up to reach the higher layer as possible, as higher as possible. Here is the distribution of the sensors we installed. They are still installed, but we had to make them very small, so it's very difficult to see them. Some other installation procedures of nodes of the second layer at 5 meters height, and then some other sensor at the lower layer. Why we decided to install sensor at different heights? Later I will show you better. Okay, there's also this outdoor sensor that gives us the reference respect to the outdoor environmental condition. That is very important because we need to work on differential quantities in order to avoid let me say noise related to the weather conditions. The control unit also has been installed here, very close to the Sala del Cinquecento, in order to collect the information and forward all the data from remote in order to control every single node that can be turned on, off, calibrated, and so on. Some experimental results, first of all related to the monitoring of the environment. We collected information for 1 year, starting from October 2012 and October 2013, both temperature and humidity for indoor and outdoor. These data we collected are achievable from a web tool, from remote, of course. Here you can see just a snapshot of this system that gives us also graphical interpretation of the values we are collecting. For every single node, we can achieve detailed information about both the environmental information and also the diagnostic data, like the quality, let me say, the health status of the system. All the information, all the data collected can be, of course, achieved during the story, let me say, looking at the database. Okay, we set up, we can compare different layers, we can compare different periods and make a lot of statistics, of course. There's also the, let me say, administration part of the system that enables the configuration of, for example, new sensors or the introduction of new rooms, of new layers and so on, or to look at malfunctioning, for example. If a node has some problems, the system tell us that there's something to do. Let me move now to some very preliminary results about the occupancy. You know, this is a very simple principle. The temperature rises to the top and the humidity saturates from below. So because of this basic principle, we decided to install sensor at different layer, different heights, because we are able to reconstruct in some way this principle, these opposite profiles of temperature and humidity. If these opposite profiles behaves, this means that probably the variations are related to human presence and not something else. Just to show you an example of an event happened last year during the Notte Bianca event. It's particular because respect to the other normal dates, in that night we have people also during the night, within the Salone del Cinquecento, and just looking at the temperature values, it's easy to see that the blue line has a very different pattern respect to the lines in the days before and after the event. Starting from this idea, we can focus more in details about the variation in the vertical profile. Here in this graph, we represented the temperature at the three different layers, layer 3, 2, 1. As you can see, the more affected layer is the layer 3, because as I told you before, the temperature, the hot rises to up, so the higher layer is the most affected respect to the other. Concerning the humidity, still you can see that the date of the event, the blue line, is different respect to the others. During the night we have different values of humidity, and as for the temperature, if we look more into the details about the profile of the humidity, you can see in this case that as opposite to the temperature, here the more affected layer is the layer 1. So layer 1 is the lowest. So the temperature is higher, let me move back here, at layer 3, and here humidity at layer 1. So in this case, that is a very effective example, because it's one of the few times that we have people during the night here. It's clear the behavior I told you before, so the opposite profiles of temperature and humidity respect to the height. And starting from the analysis of this environmental data, we applied our algorithm that is still preliminary in order to estimate occupancy. Here, as you can see, the blue line is still related to the day of the event, and the occupancy, here we have just normalized occupancy over the 24 hours. So we go to the 0% and up to the 100% of occupancy, but the focus is on the profile. As you can see, during the event, the Notte Bianca event, the occupancy is higher during the night respect to the day before and after, where we have more normal occupancy distribution during the standard time schedule of the opening of the regular museum opening. So we can see that these very preliminary experimental results confirm at least the effectiveness of the method, starting from very, very simple environmental data. So let me move directly to the next step. There is a lot of work to do, of course. First of all, we are trying to introduce new sensing functionalities. Why? Because temperature and humidity are very simple to be collected, but of course are very noisy and can be easily affected by external let me say, problems, external variations. Other sensors like CO2 or movement sensor are more focused on the human presence. So we are right now we are already integrated this sensor and will be the next experimental validation. And we would like also to forecast the indoor occupancy, because of course, as I said, the delay between the presence of people and the perturbation in temperature and humidity enables occupancy estimation after the real situation. So we are integrating now algorithms to forecast the occupancy in order to have in real time the variation in occupancy. We are integrating also the decision process. So we focus now on the check phase, as you remember in the loop, and now we are moving on the acting phase also, with the help also of mobile applications in order to provide the museum manager with some mobile tools, with web tools, able to control the system and have suggestion, support in the decision in real time. Of course, once we have this wireless infrastructure installed, we can design any other kind of smart services based on the acquisition of distributed information, like for example the navigation of tourists within the museum rooms, or localization of groups, or security for surveillance, and so forth. Okay, so I finished. Thank you for your attention.
Any questions? You may have time after the fourth presentation to ask questions anyway. This is a very interesting presentation because it is all about sensors, but you know, sensors are the beginning of interaction. And the concern was about humidity, about temperature, but it may be also connected to the central system of a museum, and it may be dynamically connected to some kind of dynamic path for the visitors. So there is a lot to dig and to find about innovation in this area too.